Hello and welcome to today's webinar on do's and don'ts in operating an NPDES laboratory, common mistakes and ways to improve results. My name is Peter Behor from the U.S. Environmental Protection Agency in the Office of Compliance, Water Branch, and my colleague Laura Paradise, and I will be operating the webinar. We're out of EPA headquarters in Washington, D.C. Assistance with your written questions are being helped by Region 6 Dallas office, Juan Ibarra, Colin Martin, Jack Arias, and Anthony Loston. Thank you guys for helping. The webinar is part of EPA's Office of Compliance's Technical Assistance webinar series for plant operators, inspectors, appliance assistance providers. The webinar series supports the National Pollutant Discharge Elimination System, or NPDES, Significant Non-Compliance SNC Reduction National Compliance Initiative. The goal of the initiative is to reduce non-compliance among Clean Water Act NPDES permitted facilities. While our focus is on helping wastewater system operators return their facilities to compliance, the webinar should be equally valuable to operators who are interested in fine-tuning their systems. Today's webinar is presented by Magda Dalamain from our Dallas, Texas Region 6 office, do's and don'ts in operating the NPDES laboratory, common mistakes and ways to improve results. The webinar will cover common misconceptions, misunderstandings found in NPDES laboratories, how to identify and rectify them in your laboratory, and how to improve your analytical testing and results, supporting documentation from both 40 CFR and Standard Methods provided. This webinar will also cover good laboratory practices and additional compliance assistance for application in your laboratory. Introducing our speaker today, Magda is an environmental scientist at EPA Region 6, working in the Clean Water Act, NPDES, and Safe Drinking Water Act programs. Magda is a graduate from Rochester Institute of Technology with her master's in atmospheric and analytical chemistries, and has been working with EPA Region 6 since graduation. Magda conducts laboratory inspections specific to the Clean Water Act and Safe Drinking Water Acts. Magda has conducted municipal and industrial facility laboratory audits and inspections and regularly provides technical and analytical compliance assistance to dischargers. She has recently received awards for her various accomplishments. Magda, I want to thank you for helping us today, and I turn it over to you.
Thank you, Peter. I appreciate it. Hello, everyone. My name is Magda Dalamain. I believe Peter just gave a great introduction, so I'll go straight into this presentation. First off, I'd like to give a special thanks to everyone that is providing support and background through the webinar system. From EPA Region 6 Dallas, we have Colin Martin, Tony Loston, Juan Ibarra, and Jack Arias. And I'd also like to give thanks to Laura and Peter, who are from our EPA headquarters in Washington, D.C. Quick overview of what we're going to be talking about today. I'm going to have a brief introduction and explanation of my goals for this presentation. And we're going to discuss the two handouts that I have given and provided for y'all. And then the meat of my, the bulk of my presentation is going to be discussing common mistakes that I have found in the past 5 or so years during my inspections of laboratories. We're going to follow up with some ways for you to improve your laboratory. And at the very end, I'm going to have some time left over for questions. I do ask that when you submit your questions through the webinar, that you try to be very detailed in the topic that you're asking your questions. While you are submitting your questions real time, I will be answering these questions or potentially reading them and reviewing them afterwards, and it can be difficult for me to understand what you're trying to ask me if I don't understand the topic. So my goal for this presentation is not to teach you how to do laboratory stuff, My goal is to help you improve what is already going on in your laboratory. So that being said, I do not consider this an introductory presentation or teaching opportunity. I consider this more of an advanced. Now we'll discuss our handouts. As Peter said, there are a bunch of different handouts available for download through the webinar. There are a few that he and Laura have uploaded, but there are two that I have uploaded for the in order to help y'all. So one is this presentation in PDF format, and then the other is select excerpts, essentially citations and a list of references for this presentation. I do want to mention that in each state, the NPDES permits can be slightly different. Each permit is required to have certain EPA language, boilerplate information. However, because each state is different, they might be located in different locations. Please keep that in mind when you're reviewing the second handout, because I used a New Mexico permit for the purposes of the citation. The information will be the same, it just might be located in a different part of your permit. In our next section, we're going to be going over the meat of the presentation, like I said, common mistakes found during inspections. So this is just a brief list of what we'll be talking about. There's two procedures that I want to talk about today, pH and total suspended solids. Then I want to briefly touch on chemical solutions and reagents, specifically expirations and labeling. And then we're going to go over documentation. So this is something that is, this is mostly where I consider the presentation more advanced versus introductory. We're going to cover calibration and temperature logs, standard operating procedures, as well as bench sheets. So first up is our pH meter and analysis. The first thing that I notice when I enter a laboratory when I'm doing an inspection is whether or not the pH probe is being stored in a storage solution or in a buffer or a water solution. A lot of facilities don't understand this, but the pH meter and the pH probe can actually be damaged if the pH probe is stored in buffer or in a water solution. So you always have to make sure that you're using a probe storage solution of some kind. The most common is KCl. However, there are a bunch of different options available on the market. You just have to figure out what's best for you. Now, a very big issue that I've encountered over the past few years is that facilities don't understand that per the pH analysis method, you have to use a pH meter that allows for temperature adjustment, whether that's manual or automatic adjustment is up to the individual facility. Personally, I think automatic adjustment is easier and better to handle. However, they can be sometimes more expensive, so you just have to figure out what's best for your situation. I also find when I'm in a facility that they might have a pH meter that actually does temperature adjustment. However, they might not be using their pH meter correctly to utilize that temperature adjustment. That therefore means that their analysis can be skewed and that they are not in EPA compliance. If you look over to this image to the far right, this is a generic pH meter. I don't expect everyone to have a pH meter just like this, but I want you to draw your attention to the far right. So this is your generic pH probe. This is your pH meter, and then between the two of them, you have this metal stick-like probe. So this is the temperature probe, and I find that a lot of facilities don't use this probe when they're doing analysis, or they're misusing it, which, like I said before, means that you're no longer in EPA compliance and your results could be skewed. You have to make sure whenever you're calibrating calibrating your pH meter, you have to make sure that both of these probes, the temperature and the pH probe, are in the buffer solutions. And then when you're taking your analysis, you have to make sure that both of these are in the sample. Next, I want to talk about calibration. So your pH meter has to be calibrated once per day or 12 hours of operation. Some facilities don't understand that they have to calibrate their pH meter before use. And additionally, if that pH meter has turned off between within that 12 hours of operation, you have to calibrate it again. I found that a lot of facilities also don't understand that whenever your pH meter is turned on or off, you have to recalibrate it. That is per the method as well as per most, if not all, pH manuals. Another thing that I see is that facilities aren't necessarily recording all of the information that they should be for pH calibration. Per the method, you have to record date, time, and slope. Slope is important. It makes sure that you have acceptable accuracy for your pH meter. The date and time is important to make sure that you are calibrating your pH meter before you actually do your pH analysis. Something that's not in the method, but is kind of hinted at in the QA/QC section of standard methods, and what I always strongly suggest facilities do, is to also record shift data while you're doing your calibration. Now, I understand a lot of you might not know what shift data is. That's fine. I'm here to explain it to you. So if you recall, the last time you did a pH calibration, the pH meter will read out, will give a reading of the buffer before you correct it for that, whatever that buffer is, whether 4, 7, or 10, or some other buffer that you may use. And you want to record that initial reading before that correction. And over time, this can show you whether the pH meter or the pH probe is essentially shifting from the corrected values of the buffers. It could also show you that the buffer might need to be replaced. It might be old, but for the most part, over a large period of time or a decent amount of time, if that initial reading before you correct the pH meter for calibration, if it continues to drift farther and farther away from the corrected value, that's an indication that your pH probe might be damaged, or it might need maintenance of some sort. It could also be an indication that your pH meter itself needs maintenance or to be replaced. So I will be pulling up an example of a pH calibration sheet. Let me get my pointer. So this is just an example of a pH calibration log. It's not perfect, but I like it as an example for a few reasons. For one thing, it says the date right here, which is required. It doesn't state the time, which is one thing that I would improve upon this. But it does also show the shift information. So they have the buffer 4, 7, and 10, and they record the shift data here, as you can see. They also show the temperature. Now, recording the temperature isn't necessarily required if your pH meter automatically adjusts for temperature, but it's not a bad thing to put in your calibration log if it does. Additionally, this facility went the extra mile and does a calibration check, so to speak, with a fourth buffer. It also shows the slope here and then the initials of the person performing the calibration. So our next topic is total suspended solids. The biggest concern that a lot of our inspectors have in Region 6, EPA Region 6, is that facilities are using the shake and pour method versus the stir and pipette. So, the shake and pour method, unfortunately, is not an EPA approved method. The stir and pipette method is. There are a few ways that you can get around this. The most obvious is you can ask your EPA office for approval for an alternate method. This can be a little bit time consuming. You need to do a comparison study and you need to keep up with that every year or 2 years. It depends on your EPA office. There is an additional way to get around using the stir and pipette in standard methods, which is if you go into 40 CFR part 136 table 1B note 2. Now this is something that's listed in my handout with the list of references. In that note 2 is a method that is EPA approved that uses the shake and pour. If you do decide to use this, the 40 CFR note 2 option, you have to make sure that on your SOPs, standard operating procedures, as well as your bench sheets, that you clearly reference what this, this method. You won't reference this specifically, but rather you'd reference the method that's listed in this note. Another issue that I find when I do inspections is that facilities will misunderstand the method when it says to filter, to wash and filter the sample twice. A lot of facilities confuse that 2 weights with the initial cleaning of the filter paper and the filtering the sample. So initially what you do is you clean the filter paper twice. You rinse it with water. Per the method, you do everything it says. Then you put it in your oven and you set it to dry for, I believe it's an hour. You take it out and you weigh it. Then you have to put it in for a second time, a minimum of a second time. So if you read the method carefully, it says 2 times, you dry and weigh it 2 or more times. The idea behind that is to make sure that the dried weight is staying constant. If that dried weight is fluctuating too much, it means that there's still some sort of liquid that hasn't evaporated from the filter paper. Per the method, it's roughly 5 milligrams or half a milligram. Any bigger difference between the 2 weights, and you have to weigh a 3rd or even 4th time. Now you apply this same idea to after you have collected your sample and you've filtered your sample, and now you're drying and weighing the filter paper with the filtrate or sample on there. Like I said, you put it in the oven, dry it, weigh it, put it in the oven a second time, weigh it, and compare the 2 weights that you just did of the filter paper with the filtrate or sample on it. And if the difference is less than whatever is listed in the method, then you're good to go and you can continue on with the rest of the method. If it's more than that, then you have to dry and weigh it a 3rd or even 4th time. Now, when I'm reviewing when I'm reviewing documentation after or during a presentation, after, during an inspection, I see that a lot of facilities aren't recording the temperature and time of the oven when they are putting either their cleaned filter paper through the oven or their filter paper plus filtrate or sample through the oven. For continuity purposes, you have to record the temperature of the oven when you put your filter paper in the oven, as well as the time that you did this, and the time that you take it out of the oven, and the temperature when you take it out of the oven. This shows that the temperature throughout the drying period was the correct temperature per the method, as well as the drying time was the correct amount of time per the method. Now I'm going to show you, an example bench sheet for this. If you have any questions for this example, I will give a little bit of time at the very end to ask, or when I'm done reviewing this example, but only for this example specifically. So first I want to point out that this bench sheet has the method cited clearly, which is a requirement. We'll talk about that a little bit later. It has the collection date and analysis date, which is good. It also says the oven temperature up here on the top right. Now, like the pH calibration sheet, this is a good example, but not perfect. It's a good example. It says that it has what the oven temperature is. However, to improve this, I would put the temperature at the beginning and end of the drying time. You can see here, though, that they very clearly show this is what they are doing for cleaning their filter paper in their initial weight. Then they have their final weight, which is where they have their filter paper plus the sample. And you'll see that they have the time that they've, I believe this is the time that they've taken the weight. They've weighed the filter paper, not necessarily the time that they've either put it in the oven or taken it out of the oven, which is, like I stated before, you have to put the time that it's in and out of the oven, but this at the very minimum has some sort of time, so you can see that there is at least an hour's difference between the two. So that filter was dried for at least an hour. Now, after that, there's a whole bunch of math and the rest of the stuff, which is not pertinent to our presentation now. So I'd like to open it to any questions, like I said, about this example. Do we have any?
Yes, we have one question that says, is there a requirement to have an in and out time and temp in the method or in supplemental EPA documentation?
That is something that I would have to look up. Whether it's in EPA documentation or in standard methods. I will get back to you on that after the presentation.
Okay, and Magda, I have another one related to the second weighings. And here Botcher asks, are the two weighings required if you're using a crucible?
Yes, the two weighings are required. And if you recall, it's not just two, it's two or more. You have to make sure that between each drying time, your weight is staying constant. That's whether it's in a crucible or on a filter paper. Any more questions?
Not related to the table.
Okay, then we will go back to our presentation. So I want to briefly touch on chemicals, solutions, and reagents. Whenever I'm inspecting a laboratory and it's gotten to the point of the inspection that I'm checking the chemical solutions or reagents, I always look at to see how they're being stored. These chemicals have to be stored at a specific temperature per the manufacturer. If they're not stored at that correct temperature, then they're going to start to denature, which is similar to a gallon of milk going bad if it sits on the counter versus sitting in the refrigerator. I find that a lot of facilities will store pH buffers or standard solutions in the back of a car or in a shed or shed-like building that doesn't have AC or heat in it. Now, if you think about it, when you enter your car in the middle of the summer, it's really hot in there. And if you enter your car in the middle of the winter, it's really cold. Drastic temperatures like that will cause your chemical solutions and reagents to denature or go bad. So it's important that they're stored at the whether room temperature, which is roughly 25 or 27 degrees Celsius, for some chemicals. Some other ones have to be stored in a refrigerator, things of that nature. They're all the information on what temperature they have to be stored on is provided by the manufacturer. Now, I also look at the expiration dates. I believe it's per QA/QC and standard methods, you have to have the open date written on your bottles, and then you also have to have the expiration date written. What people don't understand is that after you've opened a chemical or reagent or solution, that shelf life, the shelf life is shortened, or it changes from what the actual manufacturer's expiration date is. So the expiration date that the manufacturer puts on the bottle states that if this bottle is unopened and is stored at the correct temperature, then we guarantee that the contents of this bottle are going to match these different, they're going to match these different requirements if it's opened before or on this expiration date. However, once you've opened that bottle, then you open that chemical solution or reagent to possible contaminations and other things that could cause the chemical to start to denature, or in general just stop being what it's supposed to be. In some cases, just being exposed to air for too long can start to make a chemical denature, or like I said, go bad. In other cases, it's just the fact that there are potential contaminants that are getting in there and messing with your chemical. Now, I would like to draw your attention to the images. You see here, the open date is written, however, the expiration date, these are the same bottle, the expiration date is not written. That's because the facility did not understand that the shelf life changes once it's opened. They were still going off of the manufacturer's expiration date here. Now, they were lucky or unlucky enough that this manufacturer actually writes the new shelf life on the bottle 1 year after opening, or manufacturer's expiration. I will show a close-up of this in the next slide. But when I said that the shelf life changes, when I'm doing inspections, I use a general 1 year after opening rule. So the general rule is that 1 year after opening, the chemical solution or reagent is essentially expired due to either general contaminants that are accidentally introduced or exposure to air. Now, each manufacturer might have a different shelf life after opening. I personally will not be able to remember all of those dates. There's too many manufacturers, there's too many different variations of the same kind of thing. So I don't keep all of that in my head. I go by the 1 year rule, or if in this case it's written directly on the product, and I leave it as the responsibility of the facility to check with the manufacturer and see what that shelf life is. Now, once you've contacted your manufacturer or you've used this 1 year after opening, then you have to, once you've opened your chemical reagent or solution, you have to then put the new expiration date on. So in this case, they opened it 7/2017, so the expiration would be 7/2018, which is a few years before this one, which you can see. The expiration date is one year after opening, or 2021. So next, we're going to be talking more about the documentation aspect of my presentation. Thermometers in the laboratory have to be traceable to NIST, or National Institute of Standards and Technology, or an equivalent certification. In some cases, the states offer a NIST equivalent certification for thermometers. You have to have the same certification for most of your equipment and instrumentation in your laboratory. Now, what I find when I'm doing my inspections is that a lot of facilities either don't have a temperature log for all of their temperature controlled instruments, or they're only doing the temperature log once, usually in the beginning or middle of the day. So you have to have a temperature log for your temperature controlled instruments and equipment. That's on top of making sure you're recording the temperature on the bench sheets. In general, a log for the temperature at the beginning and the end of the day is appropriate for continuity. I've had some facilities that do additional temperature checks in the middle of the day. That's good, that improves the defensibility of your data, but it's not necessary based off of the language that I found in standard methods. And then so our bench sheets. I've mentioned before in TSS that the temperature of whatever temperature controlled instrument or equipment that you're using for analysis has to be recorded on the bench sheet as well as the temperature log. And like I said, at the beginning and end of each temperature dependent analysis. And this is for continuity. It's to ensure that the correct temperature was maintained during the analysis. I have an example of a daily temperature log, and if I will give some time when I'm done going over this example for any questions specific to this example, if there are any. So this is the daily temperature for the incubator for this facility. They have the date written here. This is an auto-generated thing. They have the same spreadsheet for each month, which is acceptable. And usually I don't allow auto-generated numbers in bench sheets or spreadsheets, but the date is fine. They have the analyst, so they have the morning reading and the afternoon reading, which is good. The only thing that I would improve upon would be adding the time that they perform each reading, morning and afternoon. But they have the analyst here, which is important. They also have the thermometer reading, which is important for the morning and then the afternoon. They have additional information here for QA/QC purposes, correction factor, corrected temperature, and then the serial number so they can track which thermometer is used. But that's stuff like this isn't necessary, but it is good to have. Are there any questions?
There's one question where it said for temperature logs, how many hours is to be required between beginning and end of the day?
I generally just say the beginning of the workday and the end of the workday. You want to try to get a reading of the temperature controlled instrument or equipment before you start any analysis, and then at the end when you're done all of your analysis. So a lot of facilities, usually the first tech that comes in the morning goes through, checks all the temperatures and writes down in their log, and then the last tech that leaves for the day does the same thing.
Okay, we have another question that asks, could this daily temperature log replace the ISO oven twice a day for TSS analysis?
Off the top of my head, I'm not sure what ISO means, but for TSS, you still have to record the temperature at the beginning and end of drying each time you dry your filter paper. So I would say probably not. Are there any more questions? All right, I will go.
Okay, I do have a question. This one's pretty good. Do temperature readings need to be taken every day if the incubator is only used once a month?
That's a really good question. So if your incubator is only used once a month, then you do not need to do daily readings. However, on the days that you do use your incubator, you do have to record the start date, the temperature at the beginning of the day and at the end of the day. And I would actually suggest recording multiple. So this is something that I would suggest to increase the defensibility of the data and to increase good lab practices, but this part is not necessarily required per the method. If you're only using your incubator once a month or so, I would record the temperature more frequently that day than at the beginning and the end of the day, as well as the beginning and end of the analysis. And that's mostly just to make sure that the because that that incubator doesn't sit at, might not necessarily sit at that temperature all the time, you want to make sure that it's holding that constant temperature. Especially if it's being turned off or on, it might take a while to heat up to whatever temperature is required for that particular analysis.
And Magda, we had another question related to if the equipment does not hold, a constant temperature, what should they then do?
If the equipment does not hold a constant temperature, then it needs to be replaced, or needs maintenance such that it can hold a constant temperature.
And does the laboratory refrigerator temperature need to be recorded twice daily if only standards are stored in the refrigerator?
Yes, they do, because you have to be able to prove that your standards are maintained at the appropriate storage temperature to essentially corroborate that whatever calibrations or QA/QC that you're performing using those standards, essentially that they hold up. If you can't prove that your standards were held at the appropriate temperature, then you can't prove that they are necessarily still as still have all the correct what's it called, aspects, that they're not, they haven't denatured or anything like that. Any more questions?
Not at the moment.
Okay, then we will go back to our presentation. So next is our standard operating procedure maintenance. During inspections, I usually review the SOPs, standard operating procedures, after the on-site inspection. And the first thing that I look for is always whether the facility has a full, complete citation of an EPA approved method. Even before I read the SOP to make sure that it makes sense and it's following the method, I check whatever citation is listed, and then I pull up that citation or that method, and I make sure that it's EPA approved method and that it's up to date. For an example is this standard methods. I cannot remember what method this is, but this is an example of a complete citation by stating the fact that it's from standard methods, and then this number as well as the sub method to go along with this number and the 23rd edition. You can very easily look up what this method is. So I'd be looking for a citation similar to this, but obviously specific to whatever EPA approved method there is. Then you have to make sure that your written SOPs are clear, have clear and direct instructions per whatever reference method you have here. So per EPA regulations, the facility has to have a standard operating procedure for every EPA approved method that they do for reporting purposes. You don't, it's required that you have to have this. And then I always suggest to improve the defensibility of a facility's data and to improve good housekeeping and laboratory practices is that everything that is performed in the laboratory has some sort of standard operating procedure to go along with it, similar to washing glassware or taking those daily temperature logs and stuff like that. But specific for the methods is that I found that there are a lot of facilities that haven't necessarily maintained their written procedures. Sometimes they've updated the citation, but they haven't updated the written method. Sometimes they have updated the written method, but not the citation. And you have to make sure that whatever your written method is up to date. It is using a current approved EPA method, and that the citation matches it. I've also seen that a lot of facilities will have practice methods that have changed or altered over time due to hand-me-down or word-of-mouth knowledge. This isn't necessarily a bad thing. It's always good to try to improve your laboratory. A lot of texts will say, hey, this is easier if you do it this way, that, and the other thing. However, you have to be very careful in making sure that none of this hand-me-down knowledge or word-of-mouth knowledge is affecting the actual method, the EPA-approved method. In some cases, it doesn't, but in other cases, it can actually affect the EPA-approved method, and it can alter the chemistries and means that your analysis is incorrect. There was one facility that it had two different SOPs, or I'm sorry, it had one SOP for two different locations, and each location was doing something different for the same analysis. And none of the three of them were not the same, because they had obviously not done due diligence in checking that their practice method in the laboratory was the same as the written SOP method. So it's always important to double check that your practice method is the same as your written method. So bench sheets are kind of like the biggest thorn in my foot when it comes to doing inspections, and that's because the permit actually specifically lists out a lot of information that has to be required on the bench sheet, and you'd be surprised how many facilities do not record this information. So this information right here, these bullets are pulled word for word from the NPDES permit. I've listed the location and other information on the list, the prepared handout with the list of citations. Please remember that the location might be different in your permit than it was in the permit that I used for this reference. But per the permit, you have to record the date, place, and time of sampling, as well as whoever performed the sampling. Additionally, you have to report the date and time of analysis and who performed the analysis. Whether they're the same or different people, you still have to clearly reference who did the sampling and who did the analysis. You also have to clearly cite the analytical technique or methods used. In this case, that would be referencing the EPA method or standard methods that you used. And then the results of such analysis. So this right here is kind of the gray area for bench sheets. This permit language was trying to be as vague as possible to apply to everything. So results of such analysis is that you'd go into this other bullet, which is additional information per the method. So what I like to do is when I'm looking at a bench sheet, first I look to see if they have the date, place, and time of sampling, if they have indication of who performed everything. And then I pull up the method that they're using for their analysis, and I walk through the method and the bench sheet, and I try to make sure that everything that's mentioned in the method that has to be written down or has to be performed on this sample is written somewhere on that bench sheet. Unfortunately, I don't have an example bench sheet per se, because there are so many different types of bench sheets out there. However, I believe the TSS and the pH calibration are good examples for generic bench sheets that I've already shown you. So next, we're going to briefly talk about some ways that you can improve your laboratory. Now, I suggest performing an annual internal review or audit of your facility. Now, when you're doing an internal review or audit, the important thing that you have to do is try to take a step back. You want to look through new, fresh eyes. You don't want to, the issue that I found when people try to perform internal audits is that they've gotten comfortable with what they do every day or what they do regularly. And it can be difficult for someone to take a step back and try to look at it through fresh eyes. But it's very important to look through fresh eyes so that you can catch any mistakes that you might have made either on the SOP or the bench sheets, or the calibration sheets. When I'm doing an inspection, I like to ask the technicians to walk me through all their analysis like a new employee. I ask a lot of questions and I try to pull out as much detail from them as possible so that I can make sure that they are doing what is required for them by the either the permit or the method that they're using for analysis. During your internal review or audit, you also should be reviewing any current documents against EPA methods. Like I said, your SOPs and your bench sheets, making sure that you have all the information that you need located on those pieces of paper. And additionally, you should update your SOPs and bench sheets regularly, not necessarily anytime you do an internal review or audit, because an internal review or audit can be lengthy, can take a lot of time, and potentially costs money. However, reviewing an SOP or a bench sheet is a little bit less time consuming, but still goes a long way as far as ensuring that you are within compliance and you're doing everything you need to do per your permit and your methods. Now, outside of that, you can ask for a third-party review. You can ask for another facility or another company to come in and perform an audit or an inspection for you. If your state provides this, then you can ask your state to do that. I don't know if every state provides laboratory audits or laboratory reviews. You can also ask your EPA office to perform a laboratory audit or a laboratory review. Those, in theory, should be free. Outside of that, you could do, if you ask a company or a contractor to do it, they would most likely charge you for it. And if you went that route, again, you have to consider the best option for your position, for your facility, and whatever budget that you might have. Now, thank you for coming and listening to my presentation. I wanted to ask if there are any questions that I can answer at this time. I'm not sure how much time we have left. I do want to let you know that if we can't get to all of the questions now, I will do my best to answer them afterwards. I'll get a spreadsheet with all of your questions, and I will do my best to answer all of them in a timely manner.
We have a pretty good amount of time. You did a great job presenting, and I know that the people looking at the questions are raring to go.
Yes, I have a question from Chris Malinowski, I think. He asked, please explain the DMR QA. What is it? What is involved, and which labs does it apply to?
So I will very briefly discuss this. This topic is outside of the scope of this presentation. I will follow up with a more in-depth description afterwards, but for the purposes of this presentation, I'll provide a brief description right now. So the DMR-QA is a national yearly quality assurance, quality control test that's kind of hosted by EPA Region 6 headquarters. The idea behind the DMRQA is that the facilities that participate do a blind study to show or prove to the EPA regions, EPA offices, and their states that the analysis that they're performing meet standards and meet codes, and that they can get precise and accurate analysis from them. The participation is different between regions and states, and for the purposes of this presentation, I believe that's all I'm going to go into it. Again, I will cover more information later after this presentation. Next.
Hey, Magda. We had quite a few questions about slope. A number of folks, I think, wanted you to maybe define what it is and how you find slope.
Okay, so when I was in school, I could answer this question off the top of my head. However, it's been a while since I actually had to calculate slope. I will have to answer that question after this presentation. I know exactly where all the information is in Standard Methods. I'm pulling it up as a picture inside my head, but I'm concerned that I will miss key information if I try to talk about it right off the top of my head. So I will follow up later. But that is a very good question. I didn't even think to answer it in my presentation.
There is another question where it's saying from Anna, sir, how long can you keep the buffer? And do you cover it with cyclophane?
So the buffers, I assume this is for pH calibration. Buffers vary. There's some language in Standard Methods that indicates buffers should be discarded after 6 months of use. That's indicating that the bottle of buffer should be discarded after 6 months. There's a few different ways to answer this specific question. Each time you're calibrating your pH meter, you should be getting a new vial or cup or beaker of buffer solution to perform your calibration. You can use that same solution throughout the day to calibrate, unless there's something going on with your calibration and there's an error. However, between each day, you have to get a new bottle or selection of buffer solution to perform your calibrations, whether the next day or the next week or anything like that. It's not acceptable to have a buffer solution sitting for several days exposed to the air, and it's not acceptable to use cling wrap or cellophane to cover it. Next question.
All right, Magda, from Corin Hamburg, he asks the question, if there's any guidance on the management of laboratory QA/QC using control charts, are there other ways to determine laboratory QA/QC compliance with duplicates and standards other than control charts?
This is something that I'd have to look into in order to fully answer this question. I do know that Standard Methods has an entire section in regards to QA/QC. I might also have to contact this person to ask more details as to what they mean and what they kind of answers they're looking for. But it is a very good question. Unfortunately, a little bit too involved for me to answer right now. There's a lot of those today.
Okay, and another quick question from Jamie Larson related to the bench sheets. Does the information about the sample, place, time, and sampler need to be on the bench sheet if it's already on the chain of custody?
So it's acceptable if it's on the chain of custody. It just has to be written down somewhere. I use bench sheet as a generic term because a lot of facilities that I have don't have chain of custodies, or they only have chain of custodies for analysis that they send out to a third-party laboratory to analyze. So if that information is already on the chain of custody, there's no need to repeat it on the bench sheet, as long as it's written down somewhere and it is maintained.
And one other question, someone was asking for additional clarification on recording the temperatures of a refrigerator storing samples. And does that have to be done twice a day or just once a day? And what's the regulatory citation for checking refrigerator temperatures twice daily, those that are being used for laboratory analysis?
As far as the regulatory citation, I'll have to follow up with that. If it's not on the list of citations that I provided, I'm happy to go through and find that. I do not have that off the top of my head. As far as recording the temperatures have to be recorded at the beginning and the end of the day for continuity reasons. This is the bare minimum, and it shows that in this case, the refrigerator is maintained at that required temperature for either the samples or the standards. I have talked to some inspectors that want their facilities to take temperatures hourly or switch their regular read thermometers for continuous read thermometers, which on one hand would provide more stable information about the temperature of the samples and the temperature of the standards. However, for the purposes of NPDES laboratories, I believe that it's the bare minimum of the beginning of the day and the end of the day meets the requirements.
Okay, we have another question for you.
Go ahead.
Thanks, Jack. The question asks, where can we access the new methods and SOPs to have in the lab? Is there a good place for how-tos when new methods come out?
So the EPA has not been known for providing the best guidance for new things. The only very reliable thing for me to say right now is that if there are any new methods that are approved, they will be located in 40 CFR Part 136, Table 1 and 2. There might be some documentation out there that will help people walk through new methods, or will list that this one method changed from one publication to the next publication. But to my knowledge, EPA divide that. I comfortably cannot recommend any sources that might do that for a facility or the general public. Standard Methods so EPA, all of the methods that are generated by the EPA are available for free on the EPA website. Standard Methods, you can either purchase their textbook, which has all of their current up-to-date methods in there, or you can purchase methods off of their website. There are in 40 CFR Part 136, Table 1 and 2, there are several other methods that are approved by the EPA that are not listed as EPA or standard methods. Those, I assume, would be available through a website or some other kind of book or textbook. Unfortunately, the EPA does not make it very easy to find that information. You kind of have to do it on your own.
The next question, will you clarify the citations for pH calibration once per day or every 12 hours of operation? Is this in 40 CFR 136?
So that would, if I didn't list the citation, the exact citation in my list of citations, then I'll have to follow up with this. I don't have all these citations in my head. There's just too much information, especially when I can write it down and have it pulled up for easy access. But it's not likely to be in 40 CFR. It's more likely to be in Standard Methods or in the pH manuals. It's referenced in Standard Methods in a like a check with your pH meter manual for proper calibration.
Okay, Magda, do you have any advice to laboratories in Texas that their operations were interrupted by the winter storm last week?
Yes. So my recommendation would be to be in constant, maybe not constant contact, but keep your the state and or the EPA office directly up to date on what is going on with your facility. I don't know the specifics, but I do know that most states, and especially in the EPA, are understanding in cases of severe or natural disasters. I would also suggest that they review their sanitary sewer overflow document. To my knowledge, this is a little bit outside my wheelhouse, but to my knowledge, all facilities, all wastewater treatment plants should have an SSO, sanitary sewer overflow, which will have guidance on what to do in case of usually sanitary sewer overflows. They might also have guidance on other severe weather. Your city manager might also have information on what to do in case of severe weather or natural disasters. There's nothing that I can really suggest to help your laboratory right now. It's more just trying to make sure that if you are out of compliance or if your numbers are popping on the DMR, you want either the state or the EPA to know that it's because of factors outside of your control. Next question.
Magda, Robert Edgar asked, when calibrating a pH meter, why would you be wanting to calibrate using 3 buffers instead of 2 buffers, and which is preferred?
So this is kind of a 2-tier question. From a scientific standpoint, I would always say 3 points. 2 points from a research standpoint, from a laboratory standpoint, 2 points don't make a line, 3 points make a line. And the more points on your calibration curve, the stronger your calibration curve will be. However, for the purposes of NPDES laboratories, I believe the method only requires you to use 2, but at the same time, it also says that you have to do the calibration per the pH meter. So there are some pH meters out there that will function and are okay on a 2-point calibration curve. However, a lot of them require 3 points. So ultimately, it depends on your pH meter. If your pH meter needs a 3-point calibration, then You got to do what your pH meter needs you to do. It's not going to function correctly if you only do a 2-point calibration. However, if you have a pH meter that can do either a 2-point or a 3-point calibration, I would recommend a 3-point calibration. It's better and will provide more stable data, more defensible data. However, per the method, only 2 points, I believe, is required. I will follow this up though by double checking that reference just to make sure that I've spoken correctly.
Another question from David Bloyer. When you talk about pH probe storage in a storage solution, do you mean daily storage between uses or long-term storage?
So both. When you're not using your pH meter, you have to put your pH probe somewhere, and that somewhere should be in a pH probe stored solution. You don't want to put it in a water solution or a buffer solution long term. If you're in the middle of using your pH meter, it's acceptable to put it in a water solution for a short period of time. However, once you're done with your analysis or your calibration or whatever you're doing with your pH meter, you should clean up and make sure that probe is stored in a pH probe solution.
Peter, I think it might be necessary to, we've been going for quite a while, to take a small break, 3 or 4 minutes if we could.
It's up to Magda.
Well, Magda's requesting this.
Okay, yeah,
Yes.
let's take a 3-4 minute break, 4-minute break, and come right back.
Awesome, thank y'all. I'll be right back.
Okay.
And if people would continue to place their questions in the question box, and then we can have Magda answering. We have, I'm going to read a couple of things here to get people situated for our future webinars. In the attachments, there is a handout of, as I mentioned before, of upcoming and past recorded webinars. So be sure if you haven't downloaded that already. And while this is question and answers are going on, be sure you're downloading any of the attachments that you want. We're going to continue for another 15 minutes or longer. Magda has agreed to go, if we need to, a bit longer. But we'll see how the questions pan out. We will just let me get what I wanted to say here. So once you close out of the webinar, there'll be a survey. So if you guys would answer that survey, it also helps us with future webinars and know what you thought of this webinar. The next, you'll get your certificate of attendance within 24 hours. There'll be a email link that you should look for, and as well as the next webinar is scheduled for March 25th with John Van Domelen of the state of Ohio. The topic is called Get Flexible, Low-Cost Compliance Solutions for Small Wastewater Treatment Systems. John, those of you who have been attending these webinars regularly will know that this is about John's 5th presentation for us. So he's been really great at helping us out. And I just heads up, we're working on, but not have scheduled exactly, well, we're scheduling the dates now for biosolids, and we're looking at resiliency, wastewater treatment plants planning. there's a couple of topics that we're looking into at this moment. So let me see if there's anything else I need to just make sure that we're stating before we get back to Magda. And we'll keep the webinar open for just a few minutes afterwards when we close out. So if you haven't downloaded something, but please try and download them because you won't have much time at the end to download them. And then Laura had mentioned that she'll be sending out the presentations with all the questions and answers post webinar after Magda's had a chance to look over the ones she's able to get to, because there'll be a lot of questions and hopefully she'll have the time to get to most, if not all of them.
Thanks, Peter. I wanted to say that there should be some sort of like a review or something like that coming out from Laura after this presentation. And on that, we'll have a question where you can suggest any future topics for laboratory. And I really want to ask people to, if either put it in the chat box here or in that follow-up email from Laura to list any potential topics you might want to look at. It'll help us and me organize or form or plan other presentations.
Great. Well, Juan, if you're ready to ask any other
Yes, sir. I'm ready. Okay, Magda. Sharon Kidd asked about the shake and pour method for TSS analysis. She was indicating that evidently, it's not approved. And she's currently using the 23rd edition of for TSS 2540D, which states to stir and mix a sample using a pipette or graduated cylinder to transfer a measured volume. Could you clarify the footnote that you were referring to that allows you to use a shake and pour?
So the footnote, I could pull it up on my computer, or I could
or just summarize what the footnote tells us.
I mean, the footnote doesn't list the method. It lists a different method that's approved by the EPA. It doesn't list the details of the method. It lists the title of the method and then which organization published that method. And that information is definitely in the handout that I provided. Well, it should be in the handout that I provided, but I will follow up afterwards with the title and publisher of that method if people would like me to. Usually I just tell people to look at the 40 CFR under the table.
May I interrupt just a second as people are asking questions? Get a time check, Magda. We can stop on the half hour in another 10 minutes or less, or we can go a little bit longer. It's up
I
to
think
you.
stopping on the half-hour mark is good.
Okay. All right, so another 7-8 minutes of questions and we'll close out the webinar. So just to give the audience some idea of our timing. So go ahead, Juan.
All right. I have another question. Mario Alvarez asks, we have a pH meter that automatically shuts off after not being in use. Does it have to be recalibrated when turned back on for sampling?
Yes, it does.
Oh, great. I got another quick one for you. We had a couple questions come in about whether or not electronic bench sheets are okay.
So this is a little bit of a tricky question. There are some, I want to say programs, computer programs out there that give you, that have electronic bench sheets, which are acceptable, but if you're just using Excel, that is not acceptable. The idea behind the written bench sheet is that you write in pen, and then any edits that you have to do afterwards, you have to cross it out, you have to initial, you have to sign it and date it, and any edits or mistakes that are made on that bench sheet are very clear, and they are they're not necessarily hidden. Mistakes happen. It's not really a big deal as long as you're open about it. As long as you say, nope, sorry, I wrote this down wrong. It needs to be this number instead. However, if you programs like Excel, you can go into any cell at any time and edit it, and it doesn't record that at all. With the computer programs that I mentioned, with electronic bench sheets, you can go into cells and edit them, but it flags it. The program itself flags that cell or that column or whatever, and details that it this used to be this value and now it's been changed for this value. And in some cases, they also require for you to put a reason for that cell to be changed. And it details all that information, very similar to as if it were a physical bench sheet, just, you know, in the electronic world.
Magda, I might add to that inspector that's coming in may want a copy of that, and so it may need to be made available in some manner to the inspector too.
True.
Magda, David Humphrey asks, is Standard Methods 23rd edition approved for analysis of wastewater?
So this is a question that I had in my previous presentation. It's a very good question. There are, and it's kind of a tricky question to answer. It's kind of a two-step question. So per EPA method, the 23rd edition is not necessarily approved. I can't recall off the top of my head which edition is approved in 40 CFR Part 136. However, I understand that a lot of states require that their facilities use the most recent edition of standard methods. And the idea behind this is that the states are trying to be more stringent than the EPA. And so the idea behind that being applied was that the idea of using the most recent edition of standard methods is that it's the most recent edition, therefore it's the best. It's got all the information. However, it doesn't always match up with what is approved in 40 CFR Part 136, Table 1 and 2. There is some interesting language in 40 CFR. I don't remember it off the top of my head. I will follow up with the exact wording after this presentation. That indicates that I believe the verbiage is that the year listed on the table is the last editorial version that is approved. So if that method hasn't been changed between editions for standard methods, then you can use the standard method, the method from the 23rd. However, if it has changed or been edited, then you need to use whatever edition is listed in that table. And again, that's only because I only stipulate that because I know that there are some states that require to use the most recent version of standard methods, which doesn't exactly fit with what's written in 40 CFR.
So John Dirth kind of follows up with that. Don't we have to use the method listed in 136? So what if there's I guess, a discrepancy between what EPA might require out of 22nd edition and the state might require out of the 23rd edition? How do you square that? And is that based on who issued the permit, the state or the feds?
Ultimately, you have to comply with EPA regulations first and then state regulations second, because the EPA is a federal agency. This state is obviously a state agency. However, you interact more with your state than you do with the EPA on an average day. I wouldn't take this as a blanket excuse me, I lost my word, a blanket permission to use only the 23rd edition and not the 22nd or 21st edition. But I would contact your state about it and talk to your state inspectors, and if you have to, talk to someone else. Unfortunately, this is not an easy thing to resolve on my level or even on your level, and that's because an administrator somewhere thought that they were doing a good thing. They were trying to do their job. They were trying to be more stringent. And unfortunately, the wording just doesn't match up between the state and 40 CFR. I wish I could give a better answer. All I can say is try to work with your state.
Let me ask a question on behalf of Aaron Johnson. I've seen a couple.
Let me interrupt, Juan. This is going to be the last question, so we try and end on time.
All right. I've seen a couple of questions related to this. Does the 1 year opened expiration date apply for solids, chemical solids, and pellets such as sodium hydroxide?
No. So the general rule of thumb is 1 year after opening for liquids and 5 or 7 years for solids. However, just like I said with the liquids, the manufacturer will have a shelf life. And that will vary on manufacturer, and it will vary on whatever product of theirs that you are using. But the general rule of thumb for solids is 5 or 7 years.
Thank you very much.
So Magda, let's end on that note. And I want to thank you so much for being part of this presentation today and doing a wonderful job. And thank the audience
for inviting me.
You're welcome, and thank you for accepting. And thank the audience for participation and for the questions asked. And with that, I'm closing out the webinar.